Hello, everyone, and thank you for joining us for today's webinar, Deploying Windows Apps with Docker, Draft, Helm, and Kubernetes. Today's session is brought to you by Microsoft Azure and Codefresh, during which we'll walk you through two key workflows for Windows applications and containers, the lift and shift scenario and the modern .NET Core framework. Our presenters today are Jessica Deen, Senior Cloud Developer Advocate for Microsoft Azure, and Dan Garfield, Chief Technology Evangelist at Codefresh. We'll be taking questions throughout the session, but please remember to enter them into the Q&A panel on the Zoom toolbar so we can keep track of them and address them at the end of the presentation. This session is being recorded, and a link to the recording will be sent to you later this week. Please remember to reference codefresh.io/events for upcoming webinars, as we have fresh and informative webinars for you every month. So that's it for housekeeping items. Dan, the floor is all yours.
All right, thank you for joining, everybody. We're going to be talking about Windows applications on Kubernetes, and this is something that is kind of been a long time in the works. So we're excited to share it. It's definitely got a lot more mature over the last year. Just to introduce myself first, and then I'll introduce Jessica. My name is Dan Garfield. I'm the Chief Technology Evangelist for Codefresh, and I'm also a Google Cloud Developer Expert, as well as a member of the Forbes Technology Council. And basically, I just do a lot of work around Kubernetes and containers, and then CI/CD, continuous integration, continuous delivery, productivity engineering, that kind of thing. So as we go through this, if you have questions, there's a questions button. We'd love for you to ask questions. It really helps us tailor the presentation and make it more interesting. And with that, let me introduce, or Jessica, why don't you introduce yourself?
Hi, everyone. My name is Jessica Deen. I am a Senior Cloud Advocate at Microsoft, and I am here today to talk to you about Windows containers, which Dan is right, has been a long time in the works. And I believe probably 6 to 8 months ago, we did a webinar together where we kind of talked about Windows containers, but at that time, they weren't really fully supported. And as of 1.14 in AKS or Kubernetes, you now can run Windows nodes right alongside your Linux nodes. So it streamlines and simplifies the process significantly. And we're excited to talk about that today.
Yeah, we've seen a lot more people starting to move their workloads over to Windows containers from previously using just VMs. So let's get into it. Windows containers. First off, the thing to know about Windows containers is there are some differences working with Windows containers versus Linux containers. They can be a little bit more overhead of work. There are a little bit more things a few more things you have to worry about, but they still have significant advantages over VMs. And this is really the key. Why do I want to use containers in the first place? Well, with Linux, we have tons of benefits, right? And you still have quite a few benefits of working with Windows containers. So first thing that you should know is that containers on Windows always have to match the kernel version of the host system. This is very different than Linux. Linux containers, it's just like Wild West, just throw any Linux container on any Linux host and it figures out the difference and works through it. But with Windows, you do need to make sure that those kernel versions match. So if a container is going to be 1809, it needs to have a kernel underneath it that's 1809. And that means that this kernel version needs to match on your build nodes and your deploy nodes, even if you're using Kubernetes, no matter what you're using. If you're using a local machine to build these, then of course it's going to be specific to the kernel version you're using. So this does lead to a situation where if you're doing local development with Windows containers, sometimes you may want to have different VMs available with different kernels so you can try different things out.
Yeah, and along the deploy part of that in particular, what that means is the node that you're going to be running that image on in your Kubernetes cluster. So if you build it on a 2016 node, but you have a 2019 node in your Kubernetes cluster, you're going to have a mismatch and it's not going to be able to actually run the image itself.
Yeah, and so those are things you can actually control. So you can actually have a Windows, a Kubernetes cluster. We're going to get into that with different versions of Windows running as well, if you needed to. Mm-hmm. The rest of your pipeline, and we're talking about your continuous integration, continuous delivery pipeline. The only thing that needs to be Windows specific is the build step. The deploy step doesn't need to be, tests don't need to be. Anytime you're not actually just directly running that container, you don't need to use a Windows node for your CI/CD pipeline. And this is very valuable because, as we're going to see, there's a ton of tooling for our pipelines that we want to be able to use that's Linux-based and not Windows-based. And that's okay. We can do that. And then the other thing, there's nothing special about your Docker registry. A Windows image, a Linux image, both of them can be pushed to any Docker registry without any problem. The only difference is the only time you need to match kernel versions and worry about that is when you're talking about actually running those containers or building those containers. So a Kubernetes cluster can be hybrid. Now it could be 100% Windows. Typically, all of the Kubernetes masters are always going to run on Linux. That's what they're designed to do. There's no reason you'd ever want to replace your masters with a Windows node that, like, I'm sure somebody has, but it's just you don't need to. Don't do that.
I don't actually know, and I can defer to Patrick Lang on the Windows team, where I'll give a shout out to him. You can reach out and ask him this question, but I don't actually know if running a Windows node as your master for your control plane is even supported. Partially because you have to think of what goes on in that master in the control plane with etcd and scheduler. I think those are still Linux specific. And then Windows is just part of your Windows agent pool.
Mm-hmm. Yeah, good point. So what we typically see is that people that run Kubernetes clusters that support Windows, what they do is they have different agent pools. So you have a node pool of Linux nodes and you have a node pool of Windows nodes, and you can have lots of node pools in Kubernetes, and you can basically use a selector to specify which kinds of support are needed from the node pool. So basically you can specify in your deployment that this needs a Windows node and it needs a Windows node with this specific version. And then you can just tag your agent pools with those versions. And so then you can have a Windows, Linux, you can have Windows 1809, you have Windows 2019. You can have these different pools available for all of your deployments to run into. So that was one of the questions we've had so far was, hey, can I run these Windows and Linux cluster together? Yeah, you can. You're on a single cluster with both Linux and Windows nodes. And then you just need to make sure your node selector, basically node pool selector argument is set in your deployment YAMLs so that those pods always get deployed onto the node that matches them. Before we move on, there was a question about persistent volume support and persistent volume claims in Windows containers. Jessica, do you have any insight into that you'd want to share?
I have not played with that yet, but this webinar is kind of a teaser for a session I'm doing tomorrow at OSCON. And along with myself presenting at OSCON, I will also have Patrick Lang of the Windows team, he's the co-chair on the Windows SIG group for Kubernetes. And he's the principal engineer for Windows AKS. So I can definitely make sure that I get an official confirmation as far as persistent volume claims. I do know that there have been changes to a bunch of specific specific Kubernetes features as it pertains to Windows. Last Friday, most recently, they made some updates to the way that Windows Nodes handles DNS. So I don't know if the same has also been true for PVCs.
Yeah, and we'll come back to that question in a little bit. I believe that that when you're working with persistent volume claims, you're actually mounting volumes that are not on the nodes. So I don't believe that there would be a lot of things that would be different about Linux persistent volume claims versus persistent volume claims that are working with Windows workloads. The only question is what file system you're running.
Yeah, that was going to be my thought. Like, I'm wondering if you're running maybe an NFS, like if you have an NFS volume, would you be able to mount that? But I don't know if you'd be able to mount a standard volume because that would be in a different format. I need to double check and confirm that. Yeah,
so we'll in the meantime, we'll move forward. Keep your questions coming, and we'll have some additional thoughts on persistent volume claim later. So with that, let's get into Helm, Jessica.
So for anyone who is new and is not aware of what Helm is, this is outside of Windows containers. This is just specific to Kubernetes. Helm is the de facto package manager for Kubernetes, and it was designed to specifically help you manage Kubernetes applications. It actually was originally started by a company called Deus in October of 2015. It came out of a hackathon where they just wanted to kind of create an on-ramp to Kubernetes. If you've ever created just a standard Kubernetes deployment YAML, there's a lot of room for error. There's a lot of titles, meta tags, names, different things that you're repeating. And if one is mismatched at any point, it gets very hard to manage. So Helm, being that it's a package manager, you can think of it like pip, NuGet, apt, just anything that's already your standard package manager, essentially creates your deployment files, whether that's your deployment YAML, your service YAML, your ingress YAML, your PVC YAML. It essentially templatizes that and creates a collection that's called a chart. So now you have all of those YAMLs in a templates directory, and then you have a values file that's actually going to reference your master parameters, and then your templates will parse them accordingly. So using a chart, using a collection of templates, you can actually very simply define, install, and upgrade even the most complex Kubernetes applications. Charts are also similar to images in the sense that you can package them or bundle them up. You can create a tarball file, and you can store them into Helm repos. Azure supports having a Helm repository, as does, I know, JFrog Artifactory. You can create a Helm repository. You can, and even actually Codefresh has integrated support for Helm repositories. So you can version control your charts, store them as little package bundles, and then be able to either pull them or use them in your deployment. Also, any charts can depend on any number of charts. You can learn more if you haven't played with Helm as of now. You can learn more at helm.sh. But as you'll start playing with Helm, and that's very powerful, creating a Helm chart from scratch can still be very complicated. So that leads us to our next slide, Dan, which is Draft. Draft is a tool, if you are not familiar with Draft, I'm going to explain it. If you are familiar with a tool called Scaffold, Draft is very similar to Scaffold. It works with Helm, but it was made significantly, in my opinion, easier, and it was designed to simplify the process for developers who are trying to get into cloud-native applications. Developers can use just two commands. That's draft create, which will create not only your Helm chart or a template for you to use for your Helm chart, and it'll also create draft up, which will actually deploy out your actual deployments. Draft create will also create your Docker file. So all you really have to make is really a handful of minor modifications, maybe the port that your application listens on, the image repository that you're going to be working with, if you're making it public, or pushing it to a public cloud. If you're playing with ingress, you might have to make some changes to ingress and TLS and whoever your ingress controller is. But it gives you essentially a standard framework to get started. And the way that Draft is able to kind of create these charts and these templates is it uses something called language packs. And language packs are going to detect what language your application is written in, whether that's JavaScript, Ruby, Go, you name it. Now, but by default, out of the box, it will work with C#.NET Core from a Linux perspective. But because you're using draft packs that have to detect your language, you can also add repos that essentially give you additional draft packs. And that's what we're going to showcase how you would do that with Windows. There's actually Windows packs that exist that would create you a Windows template version of Draft and help you deploy a .NET Core application from a Windows node. So we can take a look at that later. There are some prerequisites that you should know about working with Windows containers. Go ahead and go to the next slide. The first one, if you are doing that lift and shift scenario, that modern, you have a full-blown ASP.NET application, you need to be using for your build, you need to be using at least Windows 10 version 1803 or Windows Server 1803 or later. This only works from 2016 and beyond. You cannot go prior to that. You do need Visual Studio 2017. It can be any edition, even the community edition. And you need to make sure that you have .NET Framework 4.7.2, as well as the ASP.NET targeting pack for Visual Studio set up on your system as well. And then, of course, Docker. And this is going to help you actually build your Docker images. Now, I gave you a link there for that GitHub link that will actually take you to a project that we have pre-created that will actually walk you through how to use these tools with standard lift and shift scenarios. In that particular link, which when we get to the demo, I'll run through that, you'll notice that there aren't any Helm charts there. We have the standard K8s templates. The Helm charts are going to start to come into play when you kind of move and you shift over into that new ASP.NET Core on Windows scenario, which we'll go ahead and switch to that next slide. So for .NET Core, again, on your build server, on your development server, you're going to need to make sure that you have .NET Core 2.2. You have a Kubernetes cluster that is set up with Windows nodes, which you can do through the AZ AKS command line. There's great documentation on Azure that'll help you get started with that. You need a working container registry. It can be a pre-existing registry. In fact, the one that I'm using is a registry I've used for demos for the past year. I mean, primarily my demos are Linux, so it doesn't need to be anything specific, as Dan pointed out earlier. If you are using Azure, and this is kind of specific to make sure that your AKS cluster can connect to that Azure Container Registry, you will set up your Azure Container Registry, and then you have to authenticate your cluster to ACR. And you can do that by creating a profile that essentially is going to say this cluster has access to this container registry. And then you can also log into ACR on your Windows machine to make sure you can plug and play. Otherwise, if you're not using Azure, then you're going to want to use Docker login on your Windows machine and then be able to set up a Kubernetes pull secret. The setting up that managed identity authentication between ACR and AKS is specific to ACR and AKS. If you have an image registry anywhere else, you're going to want a standard image pull secret. And then you're also going to want to set up and make sure that you have the Windows Draft Pack installed, because that'll help you get started with creating your draft templates. And again, there is a GitHub link that's going to walk you through with a Windows tutorial on how to get started with Draft, as long as you have those prerequisites. And then I believe we can go to the next slide, which I think is kind of demo time. Perfect. So Dan, if you can make me the presenter, I'll kind of walk through things on my system.
You should be able to share now.
Okay. Should work. There we go. So hopefully everyone can see my screen.
Yep, looks good.
Okay. So I'm showing right now, I'm logged into my Azure portal. And let me actually back up one level here. You'll see that I have a Kubernetes service, an AKS cluster deployed. It is running 1.14, I believe. I deployed it a week ago. Yep, 1.14.0. You can see the resource group name, the location of it. But I can also go into this over here on the left that's called node pools. And when I set it up, I essentially set up 2 nodes that are Linux and 2 nodes that are Windows. So I replicated the same thing that Dan showcased as far as the diagram, how you can have Windows and Linux side by side. To show this even further from a command line level, I actually did kget nodes. K is just an alias I have for the kubectl binary. Kget nodes y, and you can see the OS image I'm using for my Linux nodes is 1604.6, and then my OS image for Windows is Windows Server Data Center. I believe I'm using 2019. That's where it'll tell you the kernel version. This is the kernel version that needs to be specific. And then you can even see, if I make this a little bit, just bring this over to the right, you can see the name of the different Windows nodes. So that'll come into play when we start working with deployments in Helm. Now, I wanted to kind of show you the Windows draft packs. So these are all the links that have been sprinkled throughout the slide deck, and then I'll make sure that there'll be a collection of these links. I'll provide them to Dan and Taryn so that we can make sure that you have access to them. But essentially, this is a set of work in progress for Draft. Draft in itself is still a work in progress. It's still in alpha stage. But if you're working with Windows, you need to make sure that you have Draft and Helm installed, which you can do through Chocolatey, which is another Windows-based package manager. And then you would set up Draft the same way that you would on a Linux system, similar to Helm. Again, if you're familiar with Helm, you do Helm init to initialize the Helm install. You'd specify your service account. You'd handle RBAC and security. which is role-based access control. And Draft is going to be very similar. You're going to initialize Draft, but you need to have Helm installed first. And then this is that part where I say that you can add additional repos for your draft packs. This line right here that I'm highlighting is very important because you need to add that draft pack repo so that it has access to essentially the pre-created template charts for Windows deployments. After that, you would go through just as you normally would from a Draft and Helm perspective. You're going to configure Draft for your Kubernetes cluster and a container registry of your choice. And then you could get started with building a sample .NET Core project. You can notice that all you're doing is maybe you're seeding into repos, you're doing a git clone, and then you're creating your draft project and you do draft up. You don't even need to actually add in draft P, C# Windows .NET Core, I don't believe, unless that's specific to Windows. Normally with draft, you just do draft create and draft up and your application will start building. So you can see draft up started, and then it gives you your success and you'll have it in your cluster. Now, what's interesting about this is once we get into the Codefresh part, I'll show you how you can see the deployment running on a Windows node. Even though it was deployed through Helm, Helm essentially just hands this off to the Kubernetes API. Now, going back over to that draft walkthrough that we told you about, these were the prerequisites where you set everything up, you have your Windows pack. And this is a little bit more streamlined if you want to get started with creating your own .NET Core application and not using a predefined git clone. You could actually create your sample application doing standard .NET new MVC and draft create of your deployment. Now, one thing, and I'm going to show you this in Visual Studio Code, you will have to update a few deployment parameters. You'll want to make sure that your namespace matches for your draft, especially if you're just using this from draft up. Your name is going to be specific. Your namespace matters less when you're using a pipeline or you're using Helm to install, because I can use Helm to set any of these variables. But when you're playing with draft for development, all of your environment-specific development tools is defined in draft TOML. So actually, if I go to Visual Studio Code, this is my lift and shift one, but I'm going to minimize that. And we should be able to find my draft TOML. You can see the same thing that I have here in my eShop on web, which this is a .NET Core Windows application. You can see the application eShop on web. The namespace I set right now is default, but in the deployment I'm going to use with this, I'm deploying it to a Codefresh namespace. I'm telling it to wait. I'm telling it that I don't need it to watch. Here's the location of my Docker file, which is in source, web pages, Razor, and Docker file. And I can see the Docker file right here, which is Microsoft.NET 2.1. And I'm obviously going to be building this on a Windows node. Now let me go back to the draft TOML. And you can see the one other thing is I'm actually going to set ingress enabled and then having a base domain. So if I wanted to use ingress with this kind of chart, I very easily can. And I just define that again as part of my draft environment variables. You can also make sure that Helm is ready after you set up draft. And this is the part that I really wanted to kind of highlight. Even though you're working with Windows containers, Helm is still working on the Linux side of things. So that's why when you have your two different pools, whether you have Linux or Windows pools, Linux is still kind of the master running the shots. The Windows is just actually running the image itself. And then you specify your tiller service accounts depending on how you have RBAC set up. So all of this is kind of the same. The last thing I wanted to talk about was that lift and shift scenario. And this is an application that we have up called Fabricam Fiber. If you followed Microsoft a lot, we use this application in a lot of demos. But this is a full-blown ASP.NET application. This is the one where you need to have Visual Studio installed on your build server. You need to have full-blown .NET framework, and you need to have Docker. Now, a lot of the draft and Helm tooling is specific to something that's a little bit more packageable, like .NET Core. You can still work with lift and shift scenarios and ASP.NET applications with Kubernetes. But right now, because I believe we don't have a draft pack for full-blown C#, you do need to, or maybe we do because there is a charts directory in here. But for this particular demo to get comfortable with it, we actually have how you can deploy these particular deployments, at least one Linux node and one Windows node, using standard Helm or using standard Kubernetes manifest charts. So you can go into the K8s directory and there's a web deployment. And this is the one where I wanted to also highlight one specific area of your deployment YAML. And you'll notice this in your charts as well. This last line, 33 and 34, and I'll zoom in here. You'll see there that it says node selector. And this is what Dan was talking about on how you can choose which node this deployment gets deployed to. This web application is built on a Windows server. It needs to go to a Windows node. So I can granulate it out even further if I wanted to deploy it to a specific version of Windows. In this, we're just keeping it simple and saying deploy this to a Windows node. Now,
the nice thing about this is if you have multiple node pools, of course, this is only looking for any node that has this kind of tag on it. And so you can have multiple Windows node tools where you intend to allow your application to be deployed to any of them. This will deploy to any of them just based on what their availability is, how large their workload is. And then of course, like Jessica said, you can specify version and actually go deeper in that selection process.
Yes, and so now let's kind of start putting some of these pieces together, because as you can see, even with all the prerequisites that kind of happen, whether it's lift and shift or whether it's .NET Core, things get very complicated when you're having to set up multiple development systems, making sure you have very specific versions of things installed. It's getting very complicated to manage, which is where I always recommend having some sort of automation system in place to automate everything you can. And that leads us into Codefresh, essentially. So Codefresh is a Kubernetes specific CI/CD tool. In fact, actually, since I have Dan on the line, I'll let Dan do his spiel for that if you want, Dan.
Sure. So yeah, Codefresh, for those of you that aren't familiar, is a continuous integration, continuous delivery platform designed specifically for working with microservices. So there's a lot of tooling that is really fantastic for working with containers. We have support for building both Linux, Windows, and Windows containers, and we also support building ARM containers natively, which is a huge performance impact. So the way the platform is designed is actually to go quite a bit beyond what traditional CIs do, where you basically just have a pipeline. Here you can actually see all your runtime environments, you can manage your artifacts, you can manage permissions, you have role-based access controls, you have audit logs, all these wonderful things. And the pipeline itself is container-based. So every single step actually executes in its own container, which is a huge advantage when you're building a pipeline, because you can basically just bring containers and use them. And we have, of course, a huge library of these things. So that's one of many reasons that people are switching to Codefresh today. But here we've got a hybrid pipeline. We have both a build pipeline that's doing all of our build work, and then we have a deploy pipeline where we're using sort of the native available Linux containers to actually do the heavy lifting when it comes to the deployment. It's really just building and pushing the Docker image that we need to do with our build pipeline.
And you'll notice, so this build project is that same eShop project that I showed you of. In fact, I actually have a fork of it here. And if you wanted to kind of play with my fork, I left the Codefresh YAML, which I want to touch on this real quick, and then we'll show you the demo. So you can see how I have two different stages, really. I have a build stage right here. This needs to go into its own pipeline. And then I have the second stage. I don't know why that's showing up red, but I'll fix that if it's a problem on my end. You would have a second stage that actually does your deployment itself. And the reason for that, we'll show you in the pipelines, is which server is actually running that particular pipeline. But this is a handy repo if you wanted to kind of get started with everything I'm showcasing. This has the same charts directory that we talked about. This was created with Draft. You can see the values, how I can specify anything, but I can also override this at runtime. And so we'll talk about that in a second. When I go to Codefresh here, you can see that the first thing I'm doing is I'm building my Docker image, and we're using that Docker file in that source web Razor pages that I showed you earlier, and I'm just gonna tag it. Now, once I tag that image name with the tag, I'm gonna go ahead and promote that over to my Azure Container Registry, which happens to be just named ACR JD test. That's all I need to do. Now, I do have some settings that are specific. The main thing is the runtime environment. This is the system Windows. That's how you know that I'm building this on a Windows build server. So rather than running this locally from my system and going through everything that I would have to do manually, it's actually simpler for me to start with creating the charts, getting what I need, and letting my CI/CD system, letting my build server handle the Windows build, especially if I don't have a Windows server that's set up to run all the tasks that I need or with all the tools that I need. So I'm going to go ahead and actually fire off this particular build. I'm just going to go ahead and hit run. And I am using a particular branch for this, which is the Patrick Lang K8's Win branch. Again, Patrick Lang is somebody I work with very closely at Microsoft, and he is the principal engineer for Windows containers. I don't believe I have any real build variables aside from the kube context, the charts name, the namespace. I'm not even sure that these are needed for build because all I'm doing is building and pushing to an image repo. We're going to go ahead and hit run. Now this is going to fire off my build process essentially, and I would actually be able to even watch as the process goes through. It's going to clone my Git repository. It's going to go through build and push. Once it gets to build, we'll click on that and take a look at it. You will notice that Windows containers will take longer to build, primarily because Linux containers can be as small as 5 megabytes, and Windows containers are around 1 gigabyte. So there is a difference as far as size, but when you think of it in the grand scheme of things, having a 1 gigabyte container versus having a 20 gigabyte virtual machine, it makes a huge difference. So I can actually see as this is building right now, it's going to start building my image. It's verifying. I have run it before, so hopefully it'll run a little bit faster. The nice thing about Codefresh is it does cache the images, it caches the image layers. So it's going to go through and build and push. We won't worry about that. I'm going to go back over to pipelines while it does that. And I want to show you the deploy pipeline. So remember, the Windows pipeline is using a Windows build server, right? My deploy pipeline is using a Helm container, which is Linux-based. So even this particular image has a Linux Docker file. I have to run this on a Linux node. Same as some of these steps. These are just Helm package, create a pull secret, and Helm install or Helm upgrade -- install. Those are very simple commands. I don't need to run them in a 1 gigabyte container. I can run them in just small 5 megabyte or 20 megabyte, however small those containers are. I can run them in very granular instances. So you can see under settings for this deploy stage, my runtime environment is the Linux runtime environment.
This kind of two-stage pipeline where you have one pipeline to build and one to deploy, we actually recommend that for Linux containers anyway, because it allows you an extra layer of control. Basically, you can have your build pipeline doing its thing, it can be running tests, it can do all these things, and then once it's ready, once you want it to be deployed and you verify that this image is good, you then push it up into your Docker registry, and Codefresh has triggers built in where you can actually trigger your deploy pipeline based on images being pushed.
Yeah, we actually have that right here set up. You can see the view trigger is I have a registry trigger. And let me go into actually the advanced options. So you can see the registry trigger. I can actually go in and show you how easy this is to add because it's not specific to Azure. You can do it with any registry really, but I just click on the type of trigger I want to add. I click on registry for this instance. And then I would choose my registry provider. I could choose Azure Container Registries, JFrog Artifactory, Quay, Docker Hub, and then I enter in my information from there, and I just set up a webhook. That's it. So on the registry part, and I'll write a blog post on how I set up the trigger if anyone's interested, but Codefresh does have documentation as well. I think that's in the Codefresh documentation right here, where it talks about how you create that webhook, which is you just run one command with the Azure command line. It's ACR webhook create, and that essentially allows your registry to be connected over to that trigger for Codefresh.
And now if you, I believe actually that your build completed, and so it pushed the image and that triggered the deployment to run.
So I'm gonna go back to builds and just take a look at that here. The nice thing is since I can see this, it looks like I can see which pipeline it's running by hovering over these little links, build and deploy. So I'm going to go ahead and click on this one, which looks like it was my deployment, and that looks good. I can actually even see here are the steps that it did. It packaged everything up. It created my pull secret for me. Now you'll notice to create my pull secret, I'm using the Codefresh CLI in a Codefresh image. So all I have to do is say Codefresh generate image pull secret and give it things like my cluster, my namespace, and my registry. And Codefresh will actually automatically create my pull secret, which is probably one of my favorite things, because when I do it through other systems, I have to manually set up a lot of other variables. And then the final command that it deployed, which it looks like we didn't deploy it with the right branch.
We had the wrong branch on the trigger. I just reset it, so it's
Okay.
started again.
So great. So let's go ahead. I want to show you that final step, and then we'll take a look at what's actually deployed. So again, it's going through all the steps. These are things you would normally do, right? I tell people, while a lot of this sounds very esoteric and specific, on a 50,000 foot view in the sky, it's still very simple. You build your image, you build it on whatever server you need based on the framework that it is. You push that image somewhere, you run your tests, you run security scans maybe, and then you deploy. And maybe your package step should really be part of build, but I put, because package in this Helm chart for the Helm image needs to be run on a Linux node, I just put it in the next logical step progression. You create your pull secret and you deploy. So I'll let this run through. I actually want to watch this step in the logs. You can see as it's deploying, I can see it's already completed. Can see that it's running my deployments, it's terminating another pod, and another one is pending. So let's take a look at that first off from our terminal. So I'm going to do k get pods, or actually let's do this. Let's do helm ls. And I can see here's revision 5, here's my eShop. It was last updated 10:39 a.m. It was deployed. Now let me go and run my normal commands I would do. K get pods -n Codefresh. We'll save the O wide. I can see it's still creating a container as another container I used previously a week ago when I was first testing this. Now remember, since it's a 1 GB container, to actually spin up the container can take a while. That's partly why I have a second one running, just to make sure. But the good news is we're not getting any kind of image pullback error or timeout or incompatibility where there's a crash loop back off. What I want to show you is where these containers are running. If I do Codefresh O wide, you could see that the node it's running on is that Windows node. So because I was able to define it as part of the Helm chart saying that the node selector I wanted to go to is a Windows node, it just took the next available one. Since it has kget pods wide, you could see the old pod that was up and running that was 13 days ago was running on a different node. So this next deployment that I just did 67 seconds ago switched to the next available node. So now if I do kget pods running wide, I see that I have one pod. I can do the same thing with kget services. And for the purpose of this, I didn't set up an ingress controller. I just did a simple public IP address, but I should be able to copy this and go take a look at it. No, I have the application up and running, and this is running again on a Windows node through Kubernetes. And just to recap, the charts that I used weren't anything fancy. They were charts that were created using Draft, using the draft packs we reviewed. So Dan, I don't know if you wanted to switch back over. Maybe you want to open up the floor for some questions.
Yeah, I wanted to share one or two more things. I really like the demo where we show, you know, from the terminal how we can actually get information about these things. But one of the nice things about using Codefresh is that you actually have a dashboard that shows everything running in Kubernetes and where it came from. So for example, here now we're looking at our Kubernetes dashboard inside of Codefresh, and we can see this Codefresh namespace where this was just deployed. And we can see everything is up and running there as expected. And we can actually go over to our Helm releases, and this will show our package that was just deployed 3 minutes ago. And you can actually throw, this is a pretty cool little feature, you can actually throw a badge into your repo that will show the currently running version of the application. And if you click on that, it will take you to essentially this page where you can see all the connected running services. Now in this case, this is a simple Helm chart, it only has one service. And we're also going to be able to see the history. this one's just running a little bit slow, but here, if I look between these two different versions, the only thing that was different was the image push, and I could actually issue a rollback right from here that would pull back the chart that we just deployed. It would go back to the previous revision. So there's a lot more control here that you have, and of course you can look into the chart and get the values and the manifest and all those kinds of things. And then if we look at our images here, if we look at the image that was just deployed, we can see that this image was created because of Jessica Deen. And we can see that it built and saved the inside of the Codefresh registry before it was promoted up to the Docker registry. And if we look at here, we can actually see what commit SHA is associated with this image, which will take us straight into GitHub. So we can actually see what code change is currently being deployed. And in this case, we can see that we made a lot of changes to the Codefresh YAML. That's the last update. So this gives you kind of a full view of traceability between everything. So there was a question asking, and someone was asking if we could show Helm charts. So if I click on Helm charts, this is going to show me all of my connected Helm chart repositories. Now, in this case, I've got kubeapps basically available, but Codefresh also has a built-in Helm chart repository, and I can add additional separate ones from any other chart repository provider. This is because Codefresh is actually the open source provider for Chart Museum, which is the most popular open source Helm chart repository. And we actually build that in to Codefresh, so everybody gets a free Helm chart repository built in along with the Docker registry. So that actually leads to another question that somebody had, which was, can you talk a little bit about the advantages and disadvantages over Harness and or Spinnaker? So I'm going to share in the chat, there is a blog post comparing Codefresh to Spinnaker. And the first thing right off the bat that you'll notice is that Codefresh is both a CI and a CD. And so this would apply equally to something like Harness. Harness, of course, is another CD platform out there. So Spinnaker is open source, and of course you can't manage it. But if you look at like the commit and deploy process, you can see that Spinnaker always has to be paired with another tool to do your CI and your builds and things. And what we really believe in Codefresh is that there's a huge advantage in having your CI and your CD and your artifacts all integrated into a single platform. No matter what artifact storage you're using, whether that's Docker Hub or ACR, having it all integrated into a single platform means we get that visibility that I was showing you, which makes it really easy to see what's going on and trace back. And actually answering the question of what's currently running and who worked on it, it's surprisingly difficult to answer in other platforms because they just don't have that level of integration with your Git provider and your deployment environments. So that's one of the big advantages. Codefresh also has a lot of speed advantages because we have built-in caching that happens automatically. And of course, the Docker-based pipeline is very easy to work with. There was another question here, which is, does Codefresh support Docker trusted registry, i.e. private registries from Docker? Yes, absolutely, as well as private registries from ACR. I think, Jessica, the one that we were pushing and pulling to is a private registry on ACR.
Absolutely. I mean, anytime, even if it's a demo, but technically that's going to be a fake production environment, I'm never going to push it to a public registry because that doesn't showcase anything that's real world. Actually, Dan, can you go over to the registry screen and show them how easy it is to set up their registry? Because this is probably one of the coolest things I really do like about Codefresh is how well everything is integrated. You just go to Docker registry and you drop down to add registry, and you literally can choose either a predefined one, maybe it's Amazon or Docker, or you just choose other registry and you give it your login information, your registry name that you want to call it. So that registry name is what I referenced in my Codefresh YAML, where I said I was using ACR JD test. That's just the name that I gave it in Codefresh. So then Codefresh goes back to the integration and says, oh, here's the credentials for this.
Yeah, very good. And there's also an option to actually add registries that are behind the firewall. So using Codefresh, this is another difference between some of those other solutions mentioned in Codefresh is provided as a cloud. So you can just use codefresh.io, stuff will build there, you can deploy from there, et cetera. But you can also use Codefresh on-prem, so you can install the entire stack on your own servers, or you can use hybrid, which is basically where we install an agent behind the firewall or on your own machine or on your own Kubernetes cluster, and all builds and everything's gonna happen using that hybrid agent. And here you can see there's this installed behind the firewall option, and this is using that hybrid agent to actually push and pull images that are behind the firewall and wouldn't otherwise be available.
Can you also go into Kubernetes and show them how easy that is?
Yep, likewise with Kubernetes here, you can see that there's actually, Jessica, you did an authorization here. You actually just did a login using Azure ID.
Yep.
And from there, you can just browse and add clusters that are in your...
Yeah, go ahead and click it. I think I have 2 other clusters. You can go ahead and see any of those pop up. We don't have to add it, but if you wanted to. And then one more link I'm going to drop in the chat window here. This is our docs for how to get started with setting up a hybrid Windows Linux node on AKS. These are the same docs that I went through to create the cluster that I showed you. So you can see I have my Windows cluster is already added. I have JDK3, JDK2S, Ignite. I could add any of those and just click add. And then I'll immediately have access. So now, Dan, go back over to Kubernetes and you'll be able, you see the nodes, but we can see anything that I have running on that cluster now, just from clicking it because I had already authorized. There we go, scroll down. I think it's probably in dev. There's a sample application. I can see I have 2 replicas and I can see the image and information from that. There should also be Helm charts running on that cluster. And that's a Linux cluster, by the way. So it's not, the name of my account you can see up in the top right says Azure Windows. That's just what I named it. I still have access to view anything. I guess I don't have releases in that. I thought I did.
Now, the cool thing is once we add a cluster, like for example, here we have this cluster that's called JDK8, JDK8. When we go to look at our pipeline, we can actually just reference that by name. And so in our deploy step, what you'll see is there's just the name reference of what cluster it's being deployed to. And oh, it's actually being set as an environmental variable on the pipeline.
Yep.
So it specifies the Kubernetes context here, and all we have to do is pass in the name. And once that's done, you know, as long as this pipeline has permissions to deploy to that cluster, which you can set with role-based access controls inside of Codefresh, then you can just reference it by name. You can do your deployments as you expect and create your resources, et cetera. So this is really a fantastic way to build out your workload. And I think the big takeaway here, where many of you are looking at Windows containers, you're trying to figure out how to migrate, you're trying to think, what's the right way to do this? You want to be using a platform that supports it natively. So Codefresh plus AKS is really the recommended stack when it comes to using Windows containers, because they're designed, they have the controls built in to do all of these normal tasks and actually optimize them. And this is a big point that the whole purpose of doing all of this stuff is that we can actually optimize the process, we can build faster, we can deploy faster, we can iterate faster, and you as a company are going to be much more successful and able to do everything you need to do. So unless there's any other questions, I would encourage you, if you want to try a POC of using Codefresh with Windows, reach out. We do have free accounts, but the free accounts actually don't support Windows. So you do need to ping us, request a demo, or there is a POC request form you can fill out. So that's a great option. And of course, Azure, you can get started for free and create an account, and you can actually, I believe you can set up your first cluster, and there's some credits in there available for you. And then there was another question here on Draft,
Yep.
Jessica.
I see that. So the question is, do Draft packages allow us to choose between Nano Server or Windows Server Core? And if all features of the pipeline are available with both image types? So remember, Draft is just a development tool, as is Helm, right? It's just a template that kind of wraps around. If you have a cluster set up with a Nano Server node, you use that node selector. And you can specify that either through a template variable in your Helm chart or that draft was created, or I have other demos. I'm trying to think of the last one I think was recorded. To show how it was recorded at Swamp Up in San Francisco in the middle of June. I actually went in and showed how using a draft, using Draft and Helm, you can change the draft template that's provided with things that are specific to your environment. So if for whatever reason the draft pack didn't have the node selector template variable, you just add that in and then choose the name of Windows or Nano Server or whatever that version is. Now, the one thing I'm gonna have to double check with Patrick is if Nano Server is supported with an AKS right now. I know specifically Windows Server is, and it has to be 1803 or higher, but I have not tested it with Nano Server. Now, the second part of your question, if all features of the pipeline are going to be available with both image types, remember the pipeline, similar to Draft being kind of a wrapper around, that's kind of what the pipeline's doing. The pipeline is just running tasks you would normally run. So if you already have defined in your Kubernetes manifest or your Kubernetes cluster already supports whatever your node scenario is, the pipeline's going to do whatever you tell it to do. Even though, remember the deploy step, even though I was deploying to a Windows node, that deploy step was, the runtime environment was Linux. It doesn't care what version of Windows or anything, because it's just deploying an image that has already been built. So the real question is going to matter if the image, if you can build that image in Nano Server, and then if your cluster can support Nano Server.
Yeah, great answer to that question. Just a last note as we kind of wrap up here on readiness. This, what we've shown you here today, is already being used by large-scale organizations. You're not the beta testers here. That happened like a year ago. So there's a fair amount of kind of expertise here. It's now pretty well battle tested and working smoothly. Of course, if you want a deeper level of support, ping us at Codefresh. We're happy to help you get up and running. We have partners. We actually partner with Microsoft to help support these workloads. And not in any small part because they're also one of our largest investors, so that's nice for us. But yeah, that's a great way to get started and get everything you need. So thank you all.
Hold on, Dan. We have one more question in the chat window.
Oh, sure.
Why do we need Draft Package Manager when we have Windows Chocolatey? There are two different types of package managers. Windows Chocolatey is going to help me set up software on my Windows system. I'm going to do Choco install Docker-desktop or Azure CLI. Those are tools that I'm setting up for my system itself, whether that's my build server, my development server, whatever I'm using. Draft is creating packages that's going to deploy your application specifically for Kubernetes. It's helping you create and set up the framework for cloud native applications. And you're ultimately going to use the charts that Draft creates, the package framework essentially, because Draft is not a package manager, Helm is. Remember, Draft works with Helm. You're going to use those packages and those charts. You're going to check them in right alongside your application. So now you have everything in one place, because when you're working with this, locality does matter. That's one of the benefits, as we talked about with Codefresh. You have everything in one place. Same thing with your Helm charts, your Kubernetes manifest, your code is now all right alongside each other. It's checked in, it's version control. And in those Helm packages and using Draft as the template to help you get started, you now have essentially a landing page for everything that you need for your application to deploy and work successfully within Kubernetes. And one more thing I don't think I made clear, Draft and Helm are completely open source. You do not have to use them with AKS. You can use them with Google, you can use them with Amazon, you can use them with Oracle. It does not matter. They are just open source tools to help streamline your native or cloud native Kubernetes application development.
Awesome. Thank you very much, Jessica. And thank you all for your questions, for your feedback. Please, we're going to send you out a follow-up link afterwards with our slides as well as the webinar itself. Feel free to share it. And big thanks to Amir for saying 10x Jessica and Dan. This webinar is very helpful for me. Thank you, Amir. This one was for you. Bye,
Thanks,
everybody.
Amir.